Hello, everyone. So today we're going to talk about our journey to move away finally from SNMP to Yang, and specifically Yang Bush here. So I'll start the talk a little bit by setting up the stage, the problem statement we're trying to solve. Talk a little bit about the key insights here to our solution and where we want to head. And then talk about our collaboration with a standardization body like ITF to progress these standards a bit further, and with excellent industry partners like Sienna here. At the end, I will talk about how we're deploying this in Swisscom as we speak today. And then I will give it to Bill, and who will carry over and give us a glimpse into what's coming up next in this journey. So with that, I'm going to start with a slide. And we all heard about digital twin so many times in the last couple of days, so I'm not going to talk too much about it, other than saying one important requirement. You have to treat it as a data product. You have to make sure it's up to date. It has near real-time state of the network. You cannot use CLI to pull the data from the network. You cannot use netconf to pull the data from the network. You cannot use MCP on the routers to pull data from the network. The network have to push the data in real time to you. You have to take care of your digital twin. So when the network operators need to understand what's the current state of the network, they have reliable information within milliseconds, ideally. With that, how to get to that point? The key pillar here is we have to treat our data as a product, meaning that it has to have semantics, it has to have SLOs on it. You need to understand how reliable this data at this moment. You need to allow sharing of data among applications, and not only the data that's coming from the network, but also the derived insights on top of that data. If you have an anomaly detection system that uses the data from the network to give you this anomaly, you need to be able to share it with other applications so they know what's the state of the network. And that's here what we talk about when we talk about the data mesh. So this is a term comes from big data studies. So what kind of application we build on top of that mesh? So we're not having data for the sake of having data. One of the things here, if you look on the slide, we actually do the collection once in our network and make it available for everyone. So your routers are busy doing routing and packet forwarding, not answering queries on a CLI or a netconf. So query the data once, push it up to a data mesh, and then on top of that, you can build all your applications. That includes something like anomaly detection, which we have currently in Swisscom, visualizations, SLO, SLI detectors, and maybe some closed loop operations on top of that as well. And as you can see here, we drive this work through standardization bodies. We're not doing something specific that you cannot use. And this here comes to this point. And this is a dense slide, but really the key takeaway here is you want to treat the data you collect from your network as a data product. You need to make sure it's traceable. You can observe the quality of the data. You can observe how much delay was spent in transit for this data. For instance, in our data collector, which is NetGoes here, it's an open source data collector. We make the metrics available as open telemetry. So all the consumers of our data can look at the state of our collector and say, hey, is this collector behaving well? Is it healthy? Does it deliver data on time? Or does it have some delays or downtime? So when you build an application on top of the data mesh, you can always go back to the source and say, hey, how much can I trust the data at this moment? And you can quantify that. We did not do this alone. It's a big journey. It started in the ITF as a standardization over 20 years ago to this move from SNMP to Yang Bush. There are multiple journeys, multiple checkpoints through the journey. And the last few years, we started to unlock the potential of all the foundations that have been laid before. This data mesh integration, the Yang Bush now is being implemented by multiple vendors, and we can leverage what have people built in the last 20 years. So what we do at Swisscom at the moment. So in the last couple of years, 25, 24, we signed multiple MOUs with multiple partners, including Blue Planet here, to co-develop this, because we cannot do this alone. We need partners, we need help, we need support to develop these features. So we started in 25, 24 with co-development together. In 26, in this year, we are wrapping now the end-to-end testing. And in the next couple of months, we will start the first deployments in production. The goal is by 27, we are fully on Yang push for all our core networks in Swisscom. And in 28, we will have a bit more of the advanced capabilities and features built on that data mesh that we are building and the digital twin we're building in Swisscom. And with that, I'll give it to Bill so he can give us what's coming up next after that.
Thank you. All right, so we've been talking so far about Yang push, which is a data collection method, a way to move beyond SNMP into a push-based telemetry, a push-based feed of data from the network. And the question is, well, that's very interesting, it's very powerful, but how does it intersect with the work being done now on the agentic level, right? We have these agents now that can take network, that can autonomously impact your network, right? How does that tie in with this Yang push initiative? And so the tie-in, though, is that if we want to have a very dynamic agentic layer that can autonomously impact our network, we have to have a very dynamic data discovery layer. We can't rely on a very restricted ability to get the data from the network into the platforms that then the agents will react to, or we're going to restrain what the agents can do. And if you think about how we pull data from the network into the assurance or analysis systems today, there's a process there, right? It's kind of there's a lot of what we call a data integration tax of first you have to have a new device installed. That device is going to publish a new MIB file, a new OID, a new Yang model, whatever it is. So that the assurance system then has to have a plugin or resource adapter of some sort that can gather that data. A software engineer has to find the documentation of that new data source, has to code that into your plugin, has to then install that into a repo that then your network team can take, install in your network. That often requires a change window. So the whole process there can take weeks, if not months, to get this data from the network into the systems that you then want to monitor with, and that's just too long, right? So with Yang push, we take that multi-month process and squeeze that down into minutes, really, because as soon as the data is available from the network, the devices will push up to the data mesh the existence of a new data stream, a new set of telemetry, for example. The data mesh will then push to an analysis system, like our assurance system, via Kafka, the existence of that data, and then the assurance system can sit there and say, all right, well, I want to take advantage of this now, so I'm going to go to a schema registry where I can retrieve the schema of that data, I can retrieve the semantics of that data, I can see what that data is, and I can immediately rebuild my pipeline of data ingestion to take advantage of that, right? So this is the work that we've been doing with Swisscom over the last couple of years to be able to kind of build this whole pipeline in so that the network itself, the platform itself, has the autonomy to match what happens at the agentic layer. And why does this matter? Because let's say we want to apply a new SLA. Let's say we want to monitor the quality of experience using some new metrics from the network. Maybe there are some new alarms we want to take advantage of to be able to understand the state of the network, right? All that's held back until we can get the data out of the network so the agents can make use of it, right? So there's a very clear tie-in here with enabling this agentic future through this push of data from the network itself. So if you take a look here, right, again, moving from SNMP to Yang push in particular, the data comes into the network. Again, we can autonomously bring that in now without a human in the loop. And then what kind of data is that, right? Well, first there's inventory data, what's in the network, what new devices are there, what new line cards or what capabilities in the network that can be expressed via the Yang push, what telemetry is out there. It can be performance metrics, it can be alarms, and then all of that knowledge is pulled together into this knowledge graph where you overlay the performance metrics, you overlay the alarms onto the topology and the inventory you have to get this unified view of what the network is. And then that forms the basis of your ability to monitor your network because you have that unified view, right? And so in this format, you could say, great, this works really well. I can, as soon as the data is available from the network, I can pull it in, make it available, push it into the knowledge graph, and I'm all set to go. And that's the first step, right? But then the limitation here is that if we talk to some of our customers today, they're already getting hundreds, if not thousands, of alarms per second in a large carrier network. They're getting billions of performance metrics per hour. There's a massive data that's already coming in. They're already culling that data down so that they're not overwhelming the storage of their systems with too much data. They're already seeing so much noise they have to sort through to kind of figure out what's going on here. And now we're saying we're going to dump even more data in autonomously, right? Maybe that's good in some cases, but then maybe that's also a little too much. So then we extend this whole framework up one more level to say, okay, what's on top of this, right? There are humans running applications today, and there are agents that will make use of this data in the future. Let's extend the ability of these users of the data to then decide what data they want to see. So maybe I'm doing an analysis of a certain set of customers, and I want to pull in some metrics on demand from the network, right? I can control from that agentic layer, from that application layer, through this pipeline, what data I want to pull from the network at that given moment. So maybe I've stored some data that's very important to me that I want to persist in my network and store in a time series database. Maybe there's some data that exists in my network. Maybe there are other data flows that I want to request on demand. By allowing your data ingestion pipeline to be very responsive to the needs of the application, right? You have much more flexibility in how you operate your network. You have much more a much more dynamic flow from that top all the way through the platform on how we retrieve data, the data we're looking at. You can shut off that data flow if you want. You can turn it on. You can focus it on a certain set of routers, focus it on a certain set of customers, and then your whole kind of data platform, the data product, as Ahmed was saying, becomes very responsive to the agents you're building on top. So this is the vision that we have of how this Yang push technology eventually evolves into something that becomes very powerful as a future agentic platform for network assurance and network monitoring. And we're already on the pathway where, as we speak, deploying into the network the initial versions of Yang push. And so this is it's a well-defined standard, a lot of work in IETF to develop this out over the past several years. And we look forward to talking to anyone interested in hearing more about this this afternoon. We feel it's a very compelling vision. We'll be at the Siena stand around 2 o'clock today to answer any questions you might have about how we're evolving this Yang push integration. And that's it.